All right, so this is completing the square. I will tell you now that these are, the first couple that I'm going to do are actually factorable, and I'm just using them so we can check our answers. Okay, to complete the square, you're trying to make this side be a perfect square like was on the other homework. So the first thing I'm going to do is move the 12. Right? And then I've got to come up with a perfect square. So to come up with a perfect square, I'm going to half this and square this. Because now wouldn't this side be x plus 2 and x plus 2? And some kids start skipping that step. So that's x plus 2 squared. And then I can use the square root property. But I can't just add 4 to one side, so I would add it to the other. So this side would be 16. Okay, so now this goes back to what we did with the absolute values. I would square root both places. Okay, and x plus 4 or x plus 2 equals a negative 4. I'm going to subtract 2. And those are my two answers. Now, if I would have looked at the original problem, and I'm just going to come over here and just work this. The original problem was x squared plus 4x minus 12. Right? I could have made my table factors of a negative 12 that subtract to 4 are 6 and a negative 2. So this would have been x plus 6, x minus 2. So my two roots are a negative 6 and a positive 2. So I could have done this question by factoring, but I'm trying to show you how to complete the square. Okay, so here's another one that I could have done by factoring, right? So I'd have x squared plus 6x plus 8. So that would have been x plus 4 and x plus 2. Factors of 8, that add to 6. Those slap me in the face. I didn't make a table. So my two answers are a negative 2 and a positive or negative 4. Okay, and that's going to be the faster way to do this problem. All right, but I'm just trying to show you what to do on completing the squares. So this next one, the 8, is not a perfect square. So you must get it out of the way because it won't be a complete square. So I'm going to move the 8 over. Okay, and then you take this middle because you want a perfect square and you want to make this side a perfect square. This would be x plus 3 and x plus 3. So this is x plus 3 squared, right? And so if you add 9 to one side, you got to add 9 to the other side. So that's 1. So now I square root both sides and I get x plus 3 equals 1. X plus 3 equals a negative 1. So I would subtract the 3. And I would subtract the 3. And those are the answers I got while factoring. Okay. Now, completing the square does get a little bit harder when you're dealing with a values. So this one's going to be a tad bit harder. Again, this is another one I could have done by factoring because I could pull a 2 out. And I could say factors of 6 that subtract to 5 are negative 6 and 1. So my answer is 6 and a negative 1. So this is going to be way faster to do this one by factoring. But I'm going to show you the steps of completing the square because they're not all going to be factorable. First, 12 isn't a perfect square. That's the first thing you always do is move that over. The second thing, 2 is also not a perfect square. So you must pull that out. There's no other option. That's why some kids struggle with this is because they try to make up their own rules. It's got to be, this has to be a perfect square, and 2 is not a perfect square. So you got to get it out. Ooh, yep. Okay, so now you're going to end up with some fractions because you're going to half this, which is 5 halves, and square this, which is 25 fourths, right? And you can use a calculator. I don't know that I would give you a calculator on this one. I think you should be able to square 5 halves. Okay, now my boxes, usually if you look at the last two, my boxes were the same, right? My boxes were the same. This case, they're not the same because this one has an A value out in front. So I have to take 25 fourths times 2. So 25 fourths times 2, that would be 50 fourths, which reduces to 25 halves. Yes? So on this side, it would be x minus 5 halves, x minus 5 halves. So that's my squared. And on this side, 24 halves, right, is 12, isn't it? So 24 halves plus 25 halves is 49 halves. Yes, I would expect you to be able to do that without a calculator. Okay, those aren't huge numbers. Okay, so now I would solve. The first thing I'm going to have to do is get rid of the 2. So 49/4. And then I would square root both sides. So I'd get x minus 5/2 equals 7/2. X minus 5/2 equals a negative 7/2. So I would add 7/2 and get 12/2, which is 6, which is what I got right here. And I would add 5/2 and get a negative 2/2, which is a negative 1, which is what I got over here. So way faster just to factor, right? A lot of kids don't want to do the factoring, but after I show you your other option, it's probably the better one, okay? All right, so the whole point in this is for a question like this. So if I graph this on my calculator, it doesn't have nice roots. And if I do factors of a negative 12, that subtract to 6. 12 and a negative 1 is 11. 6 and a negative 2 is 4. I just jumped 6. This thing is not factorable. So I'm going to get, and I'm going to complete the square. So I move the 12 because 12 is not a perfect square. And I half this and I square it. And there's no a value, so it's going to be the same. So this side is x plus 3 and x plus 3, which is x plus 3 squared. And this side is 21. So I would square root both sides. So I'd have x plus 3 equals plus or minus the square root of 21. And then I subtract the 3. And so those are my 2 answers. And you can't get those by factoring. Okay, you can get them by completing the square or by the quadratic formula, and you are going to have to be able to do both in the future. So we will go over both. Okay, so let's take a look at this one. Okay, again, if I try to factor it, factors of a negative 12, that add up to 9. Negative 1 and negative 12, that adds up to 13. Oh, no, it's got to be, sorry. I need them signs to be different. So that's 11. And then a negative 2 and 6, that's 4. Negative 3 and 4, that's 1. None of them add up to 9. So the first thing you do is move the 4. And then you take out a negative 3 because negative 3 is not a perfect square. When you take a negative out of 9, you get a negative 3. Right? So now you're going to half the 3 and square it. So this is 9/4. So this side is x minus 3/2 and x minus 3/2, right? Okay, and so then I would times that by 3. So this is going to be a negative 27/4. Okay, because if you need to write it to the side, I think you should be able to do this without a calculator. 3 times 9 is 27, right? So wouldn't this be 16/4? So 27, negative 27 plus 16 is what, 11? Negative 11/4, right? Okay, and so then I would divide by a negative 3, which is the same thing as multiplying by a negative 1/3. So a negative and a negative is a positive, right? And then I would square root both sides. And I said on these ones for what we're doing now, I would let you leave it as 11/12 and not rationalize it. But we are going to deal with that a little bit more in the next couple of days because by the time we take the next test, I will not accept 11/12 as an answer. So you would have to rationalize it, but I would take that for right now. Okay. And because of that, I'm not going to give you any on the test that give you weird denominators like that. All right.